The next topic in general science is from chemistry, that is pH scale and indicators. And the question says the pH scale measure the hydrogen ion concentration in a solution. What does P mean in this? Okay, so you have these four options. Student, it is a tricky question. Okay, so all of us knows that P is power of hydrogen, or sometime in some text it is written it is potential of the hydrogen concentration. Sometime it is written as power only. Okay, but remember it is potence. Potence is basically the word in German which means power. Okay, so for this particular question all are right, but the option B is more right because it is in German and it means power in the German. Okay, so those who have given option B, they are right. And we have seen the pH scale related pointers in our theory classes, where we have discussed basically the pH tells how acidic or basic is a water based solution, and this scale was given by Danish chemist SP Sorensen in 1909. And a very important one, that pH scale ranges from 0 to 14, and why it is only 0 to 14 that we have already seen. Okay, so between like 7 is neutral, less than 7 is acidic, and more than 7 is alkaline or base in nature. And we have also seen the pH as mathematical number, where we have defined pH as negative logarithm of the hydrogen ion concentration. It means that more the higher hydrogen ion concentration, pH will be low. Okay, this is very important. These are generally asked in the exam. More the hydrogen ion concentration, it will be acidic. Low hydrogen ion concentration, it is basically the basic or alkaline in nature. And a very important pointer that we have seen, that if you jump from one pH to another, since it is an log 10, it is base is 10, so it will increase 10 times change in the acidity. Okay, so if you go from 1 to 2, it means that pH of 1 is basically 10 times acidic, more acidic than the pH of 2. Why it happens? Let's see. So if a hydrogen ion concentration is pH is 3, so it means 10 power minus 3 mole per liter, which is pH 3. Similarly 10 minus 4 mole per liter for pH 4. And if you compare 10 minus 3 by 10 minus 4, it is 10 times more. So pH 3 is basically 10 times more than pH 4. Okay, all such pointers we have related in our theory class. Okay, let's see the next question. This is a very good question. So for general science, such type of question are generally asked in exam. Like you have been provided 3 test tube. One contain distilled water, the other 2 contain acidic solution and basic solution respectively. Okay, so you have 3 test tube. One has distilled water, the other has acidic solution, the next one is basic solution. Which one of them will turn red litmus blue? Okay, so it is like in our daily life also, we want to check the substance present in the tube, whether it is acidic or basic. So the litmus test, that is the indicator, is used. Okay, and we have seen in our theory classes that basically if the litmus is turning to blue, it means it is basic in nature. Okay, it is basic in nature. So you can remember in this way what is the target. Like if it is shifting from red to blue, blue is what? Base. So B is base. Okay, B stand for base, B stand for blue. So if it is turning blue, it means it is base. Okay, and we have seen that there are many indicators like natural indicators, olfactory indicators, universal indicators. And in the natural indicators, this litmus is very important. Litmus is a natural indicator. and this is obtained from the light chain. This is very important MCQ which is generally asked in the exam. Litmus is obtained from the light chains. Okay, light chains are what? It is basically algae plus fungi which you found generally on the bark of the tree, and they are also known as popular indicator whether it is pollution is there or not. From that light chains you can conclude that. Okay, so basically if litmus is turning to red, it means it is acidic, and if litmus is turning to the base blue, sorry, it is base. Okay, so how to remember this thing? So remember, red is a danger, so acid is highly concentrated, so you can think acid when it turns to red, it means it is acid. When it's turned to blue, it is base. And litmus test, as I told you, that it is used to identify the nature of solution. So when blue litmus turn red, it means it is acid. Okay, and if red if you have blue litmus turn red, it means it is acidic. If blue litmus does not change, it means it is base, and if blue litmus does not change, it can also be neutral. Okay, and if you are changing the red litmus to red litmus means there is no change, it means it is acidic, whereas if you have change of color from red litmus to blue, it is basic in nature. Okay, so overall what is the theory? That if it turns to blue, B stand for base and B stand for blue, so base will turn into blue. Okay, the next one is which one of the following matches is not correct. Okay, so what he is telling, he is giving you the pH number. So pH numbers of the commonly used items are very important, which we see in our daily life. Okay, so pH of blood, it is 7.4, it is near to the neutral, so this is correct. pH of pure water is 7.5, this is wrong. pH of pure water should be exactly 7.0. okay, it should not be 7.5. Vinegar, as you know, it is acetic acid, so it is 2.2. okay, pH of milk is like border to 6 and 7, so it is also right. Okay, so option B is incorrectly matched. And we have seen the various pH values of different items, and this scale was given by SP Sorensen, and pH range from 0 to 14, as I told you earlier. And out of these, if you see, the important one is the acid rain. Okay, acid rain pH is less than 5.6. okay, and if you talk about human blood, it is 7.4, and human body is around 7 to 7.8. And this is very, very important, that distilled water, pure water which is having no impurities, no chemical, and the neutral solution at 25 degrees centigrade, it is 7. This is very important. Okay, just remember, distilled water, pure water, neutral solution, all will have the same pH value of 7. And if you talk about milk of magnesia, and that is sodium hydroxide, it is 10.5, and it is the highest pH in the table. Let's see the next question. Which of the following has pH value of 7? So as I told you, that pure water and neutral solution, these two have pH value of 7. Okay, basic solution will have pH of greater than 7, whereas acidic solution will have pH less than 7. So option E, more than one of the above, is the right answer. Okay, let's see the next question. Hydrogen ion concentration of which of the following solution is highest? So what we have studied, that if the smaller the pH, okay, then it will be the highest hydrogen ion concentration. Okay, so if my pH is the smallest one, it will have hydrogen ion concentration more. So option D, those who have given, they are right. Okay, Let's see which represent the increase in pH value from 7 to 14. Okay, so you are moving from pH 7 to 14. It means you are decreasing the hydrogen ion concentration, right? So option, it is like both are correct. Like if you have OH negative, that is hydroxide ion concentration is increasing, or you can say it is decrease in hydrogen ion concentration. These two are right basically. So C and D both are right, because if you are decreasing the hydrogen ion concentration, it is moving to the basic, since it is telling from 7 to 14. So 14 is that you will not have any hydrogen ion concentration. That's why D is more appropriate, because he is telling from 7 to 14. Okay, so it's option D only. So increase in OH concentration will be highest in 17 pH value. What will be the pH value if the concentration of hydrogen ion is 1 into 10 power minus 5 mole per liter? A very simple one. You know pH is what? pH is negative log of hydrogen ion concentration. It is 10 power minus 5. And if you do some mathematics, it is log base 10. So you will have minus 1 into minus 5 log 10 base 10. So this become eliminated. So minus 5 into 5 minus 5, it is plus 5. So option B is the right answer. Let's see the next question. Which the pH of a solution changes from 3 to 6. Okay, hydrogen ion concentration will become what? Okay, so since it is moving from acidic to basic in nature, so the hydrogen ion concentration will decrease. Okay, so it will not increase, so this is eliminated. Okay, so as we have told you that if you are moving a unit in the pH scale, it is increasing 10 times. So here it is increasing 3 to 4, 4 to 5, 5 to 6, 1, 2, 3. So 10 power 3, that is 1000 time it is decreasing. So option D is the right answer. Got it? So we have seen in the first slide itself how this unit changes from like if you are moving from one unit to another, why it is 10. So you can go back and just go through it. Okay. Yes, we have already seen that if you are changing, each pH unit change is correspond to the 10 times change in acidity. So here we have moved 1, 2, 3 times, so it becomes 1000 times, and it is moving to the basic, so it will decrease. So decrease 1000 times. Which of the following solution is alkaline? Okay, so as you know that if you have pH is equal to 7, it is neutral, and if you talk about hydrogen ion concentration will be 1 into 10 power minus 7 mole per liter. Okay, and since hydrogen ion concentration is basically he is asking alkaline or basic, so it will be reduced. Reduced means it will increase. Okay, it should be less than 1 into 10 power minus 7. Okay, don't confuse with greater than. Greater than means it will move toward acidic, but if it is reducing more, and if I write say 1 into 10 power minus 8, the pH become 8. So it is basically basic in nature, alkaline in nature. That's why option A is right answer. In universal indicator, what does pH value of 4 to 5 indicates? Okay, 4 to 5 indicates. So in universal indicator, pH value of 4 to 5 indicates they are weak acid. So in the scale, if you have the 7 is neutral, the 0 is strong acid, and 14 is strong base. So if you have range 4 to 5, here it is strong acid, so you can say that they are weak acid. So option A is the right answer. Here it is the strong acid, here it is base, here it is weak acid, here it is weak base. Okay, the pH value of a salt is 12, then it is a salt of what? Okay, so remember, if the pH value of salt is 12, it means it is basically toward the base. Okay, so base is stronger. Okay, that you have to remember. If it is 12, so it should have a strong base. That's why the overall salt is basic in nature and it is a weak acid. Okay, so option C is the right answer. This is a very interesting question and the final question for today set. The pH of dash cannot be detected by direct use of pH paper. These are the 4 options. You know that sodium bicarbonate is a base, juice is acid, water is again neutral, and ink is again a solution. This is a very tricky question. In fact, like whatever the pH things we are discussing, it is only valid for the solution. I write it. It is only valid for the aqueous solution, water-based solution. Since he is talking about solid sodium bicarbonate, it will not be detected by the pH paper. So option D is the right answer. Which one of the following is commonly used as an indicator to measure exact pH? Okay, exact pH. So remember, it is a universal indicator. It is not the synthetic indicators, not the natural indicators. It is universal indicator are used to measure the exact pH, and in the theory classes we have seen all such pointers. When litmus is taken into a borax solution, okay, what it turns? Okay, so what you should know, that what is this solution, whether it is acidic or basic. Yes, borax is basically a basic solution. Okay, so if it is basic solution, then it should turn the litmus to B. B stand for blue, so the litmus should turn into blue. What is the color of alkali? Alkali or alkaline or base, both are same. And here he is using synthetic indicators like phenolphthalein and methyl orange. And remember that phenolphthalein, if it is base, it will be pink in color. So option B, pink in the base and yellow the methyl orange, right?